Hey everyone, welcome back to Checkmate Scholars. In today's video, we'll be going over the 2025 5th grade math STAAR test. Make sure to like, share, comment, and subscribe to stay updated on our new videos. Also, if you are a new Checkmate Scholars member, make sure to check the links in the description. There you'll find the link to the Checkmate Scholars sign up. Remember, new Checkmate Scholars members get an hour of free tutoring. Also in the description, you should find the TEA website link. That'll send you straight to the TEA website where you can access all of these released STAAR test practice questions and give them a try on your own. All right, let's get started in today's video. All right, question number 1 reads, the graph shows 3 points that follow the rule y equals x plus 4. Which table contains only values that follow the same rule, y equals x plus 4? All right, so our question is centered around this equation, y equals x plus 4. All right, so what does this equation mean? Okay, y equals x plus 4. This equation means for every value of x, we need to add 4 to get our value for y. So if x is 1, that means y is going to be what? Y is going to be 5, right? If x is 10, rewrite that. If x is 10, then y is going to equal what? Y is going to equal 14. So whatever we get on x, all we're doing is adding 4 to it, okay? That's all we're doing. That's all we're doing here. And so let's go to our graph, okay? So here on our graph, we have our x-axis, which is the one at the bottom, and we have our y-axis, which is the one that goes up and down. All right. So let's look at some of the coordinates, right? So remember, for your coordinates, you're always going to have your x value first, followed by your y value. So these are coordinates. Coordinates are just going to be the x value, comma, y value. So let's look at this one right here. Okay, where are the coordinates? If we trace down to our x-axis, we see that this is 3. And if we go to our y-axis, we see that this is 7. Now, does this fit our function? Does this fit our equation? Yes, it does, because x is 3. And if we add 4 to it, we get 7, which is our y value. So this works. The same thing with this coordinate right here, right? If we trace down, we get to 4. 4 plus 4 is 8. Same thing for this coordinate right here. If we trace it down, we get 8. If we trace it across, 8 plus 4 is 12. So this works perfectly fine. So now we need to see how we can use this table in this equation in our tables. So we have a few tables in our answer choices. Let's see which one follows our rule. Answer choice A. Answer choice A, let's look at this one right here. Answer choice A has x as 7, right? So if x is 7, to get to y, we need to do what? We need to add 4. So so y should be 11, but that's not what we get here. So A is incorrect. A is wrong. Let's try, let me erase this. Let's try answer choice B. All right, answer choice B says that x is 5, okay? X is 5. To get to y, we need to do what? We need to add 4. We need to add 4. So our y should be 9, all right? So it checks out for our first set of coordinates. So this is correct. Let's check out our second one. X is 6. 6 plus 4 is 10. That checks out. Let's look at the final one. X is 19. 19 plus 4 is what? 23. So this doesn't work out. So if one part of your answer is wrong, then all of it is wrong. So B is not the answer. Let's check out C and D. You can pause the video now and try out C and D on your own. All right. So let's keep going. So let's check out C. Our first one, x is 0. 0 plus 4 is 4. So that's correct. What about x being 6? 6 plus 4 is 10. So this is correct. What about the last one? X is 19. 19 plus 4 is 23. So this is correct. Now, we can just circle this and leave, but we just want to make sure that we've chosen the right answer. So let's check out D. X is 1. 1 plus 4 is 5. So this is wrong. We don't even need to check out the rest, because remember, if one part of your answer is wrong, the whole thing is wrong. So for question number 1, the correct answer is C. All right, question 2 reads, Paul counts the number of cups, mugs, and bottles in a cupboard. His data are shown in this frequency table. So you have your kitchen items. The type is on the left side and the tally is on the right side. So we have 12 cups, we have 4 mugs, and we have 3 bottles. How does the number of cups compare to the number of mugs or the number of bottles? Select an answer from each drop-down menu to create a true statement. The number of cups in the cupboard is 3 times, 4 times, 1/4, or 1/3 the number of bottles or mugs. All right, so in this question, I think I want to focus on bottles. So let's focus on bottles first, and then we can try out the mugs. All right, so Paul has 12 cups, right? He has 12 cups, and then he has 3 bottles. He has 3 bottles. All right, so how do we go from 3 to 12? Right, well, we can add 9, but our answer choices weren't inclusive of adding. They were more related to multiplication or division, because they said 3 times or 4 times. They also said 1/3 or 1/4, right? And so if that's what we're going with, then we have to realize that 3 times means to multiply, whereas 1/3 means to divide. But how do we go from 3 to 12? To go from 3 to 12, we can use multiplication. We can multiply by 4. So the number of cups is 4 times the number of bottles, which is 3. All right. So the number of cups in the cupboard is 4 times the number of bottles. The number of cups in the cupboard is 4 times the number of bottles. So this would be the answer if we were working with bottles. But let's say I had a preference for mugs. How do we do that? Well, it's the same process, all right? So we have 12 cups and we have 4 mugs. So how do we go from 4 to 12? We multiply by 3, all right? And so the number of cups in the cupboard is 3 times the number of mugs. So for this question, you had 2 possible answers. If you chose mugs, this would be the answer, 3 times and mugs. But if you chose bottles, then the number of cups in the cupboard is 4 times the number of bottles. All right, guys, let's move on to question number 3. Question number 3 says, the models shown represent the fraction of all cookies sold at a bake sale that were vanilla and the fraction that were chocolate. So you have a vanilla portion, it's represented by a square. We have some triangles within that square, and then we have a shaded or partially shaded square that also represents the chocolate. What is the difference between the fraction of chocolate cookies sold and the fraction of vanilla cookies sold? All right, so the difference. So this tells me that we are subtracting, and we're subtracting 2 fractions. We're subtracting 2 fractions, all right? So let's look at our vanilla. What's the fraction for the vanilla? So looking at the vanilla, we have how many shaded portions? We have 2, right? We have 2 shaded portions, okay? Out of, let's see, we have 1, 2, 3, 4, 5, 6, 7, 8 total pieces of vanilla chocolate. All right, and what about Wait, vanilla cookies. So we have 2/8 of the vanilla cookies that were sold. Okay. Now let's look at the chocolate. The chocolate is represented by 2/3. Okay. 2/3. All right. So obviously, looking from the picture, we can see that more of the chocolate was sold than the vanilla. All right. So now, how do we subtract these? Well, you can't subtract fractions if they have different denominators. That just won't work. To subtract fractions, you need to have the same denominator. All right? You need to have the same denominator. So how do we do that? All right, well, let's try and make these a bit smaller. So we have 2/8 and we have 2/3. Now we want them to have the same denominator. So how do we do that? Well, we're gonna do this method. So basically what we're gonna do is we're gonna multiply going across and going diagonal. All right, so we're gonna do that, and then we're gonna flip it. Okay, so let me do the other one on this side. So we have 2/8 and 2/3. Right, and we're gonna multiply across from the 3 and diagonal from the 3 as well. So we're gonna do the same thing but on both sides. All right, and so that's gonna get us two fractions that have the same denominator. All right, so let's multiply on the right side first. So we have here 2 times 8 and we have 3 times 8. All right, now remember, this represents the chocolate, right? So our 2/3 fraction represents the chocolate. So this is going to be the new fraction for chocolate. All right, so this is the chocolate that we're going to get. So our new fraction is going to look like this. So we have 2 times 8 on the top. That is going to be 16. And on the bottom, we have 3 times 8. That's going to be 24. All right, so our new fraction for chocolate is 16/24. And if you divide this back by 8, you're still going to end up getting your 2/3. All right, so that's how we know that we're correct. All right, let's move on to the vanilla cookies. So on the top, we're going to multiply 2 times 3. That gets us 6. On the bottom, 8 times 3, that gets us 24. So now we have our new fractions. All right, so chocolate right here is represented by 16/24. Vanilla is represented by 6/24. All right, now we subtract. Let's subtract. So when we're subtracting fractions, remember the denominator stays the same. So 24 is going to stay on the bottom. 16 minus 6 is 10. All right, now let's stop here. Our answer we got was 10/24, but we do not see that answer in the answer choices in A, B, C, or D. All right, so what do we do now? Well, now we have to do something which is called reducing our fraction or simplifying our fraction. So let me create some space up here. All right. So our new fraction, which is the difference between the two, is 10/24. Now, how do we simplify this? What number can we use to divide 10 and 24? What number could we use? So that number is going to be something called our greatest common factor. What number can we use to divide both the 10 and the 24? Well, we can use 1, right? 10 divided by 1 is 10. 24 divided by 1 is also 24. But that doesn't get us anywhere. We want to reduce it. What about the number 2? Can you divide 10 by 2? Yes, you can. All right, you could divide 10 by 2. Is that the greatest common factor? Yes. Can we go up to 3? No, you can't divide 10 by 3. You could divide 24 by 3, but not 10. You can't go up to 4, 5, 6, 7, 8, 9, or 10. So 2 is our greatest common factor. So we're going to divide the 10 by 2. All right, so let's do it this way. Divided by 2. Divided by 2. And that gets us what? That gets us 5 over 12. So that's our answer, 5 over 12. That means C is the correct answer. Hey everyone, if you're interested in a free 1-hour tutoring session with Checkmate Scholars, make sure to click the link in the description. That link will send you to a Google document where you can sign up for your student. All right, let's get back to the video. All right, let's look at question number 4. The Venn diagram shows a way to classify shapes. At least one right angle, at least one pair of parallel sides. Select 2 shapes that belong in the shaded region of the Venn diagram. All right, so the shaded region basically means that we need something, a shape that has this characteristic and this characteristic. All right, so the shapes need to have at least one right angle and at least one pair of parallel sides. So let's look at what we have. Let's start with the right angle. What is a right angle in the first place? A right angle is going to be an angle that is 90 degrees. All right, it's going to be 90 degrees. This angle right here is 90 degrees. All right, so we're looking for these tiny squares. All right, so this fulfills that requirement. This does and this does. That means the triangle, the pentagon, and the rhombus do not have at least one right angle. Okay. All right, let's keep on moving. Our 2 shapes also need to have at least one pair of parallel sides. Parallel sides are like train tracks. This one does not touch the other one. All right, so that's what we're looking for. And an easy way to remember parallel lines is if you write out the word parallel. If you write out the word parallel, you'll notice that these 2 lines will never touch. They will never touch. Excuse my poor drawing or writing on the computer, but parallel lines do not touch. Okay, so let's take a look at our shapes. If you look at this trapezoid, you'll see that this line and this line will never touch. They touch the other 2 lines, but they will never touch. The top line and the bottom line won't touch. So that works out. Our rectangle also has a set of parallel lines. These 2 won't touch, right? And these 2 won't touch. So that works. Our triangle, on the other hand, does not have parallel lines. Notice all the lines touch each other. This one touches this one. This one touches the side. So none of those work, right? So that means the 2 shapes that belong in the shaded region of the Venn diagram are the rectangle and the trapezoid. All right, on to question number 5. The table shows the weights of different types of chickens in pounds. So we have the Ancona chicken, that's 6.01 pounds. The Cornish chicken is 8.6 pounds. The Leghorn chicken is 5.699 pounds. And the Brie chicken is 6.195 pounds. Caroline wants to list the weights in order from least number of pounds to the greatest. Which weight should be third on her list? All right, so whenever you're comparing numbers, especially when it comes to numbers with different types of decimal, different types of numbers after the decimal, I think it's best to use a place value chart. Okay, so you can quickly draw this out if you can. All right, so a good thing to have is a place value chart. All right, so what we're gonna have here is going to be our ones. We're gonna have our ones place. Okay, we're gonna have our decimal there. We're gonna have our tenths place, followed by our hundredths place, followed by our thousandths place. All right. So So you have our tenths place, our hundredths place, and our thousandths place. All right, now let's put our numbers into our place value chart. So we have 6.01, we have 8.6, we have 5.699, then we have 6.195. All right, so how do we order these from least to greatest? Well, you always want to start from the left and move to the right, okay? And you only move to the right when you have maybe two numbers that are similar. All right, so we're gonna start from the left and move to the right. So we're going to the right side, basically. So we're starting on the left with the ones place value right here. Which one is the smallest? The smallest number we have here is a 5. So that means our leghorn is going to be the least at 5.699. All right, what's next? 5.699. So now we are looking at the ones place again. So we've taken care of the 5. Now which number comes next? Okay, which number comes next? Well, we have a 6. The 6 is the next smallest number, but we have 2 of those. So now we're gonna move over to the tenths place, which is right here. We're gonna move over to the tenths place. All right, so which number is smaller, 0 or 1? Obviously it's the 0. So the next number we're gonna have is 6.01. All right, so we can cross this out. Now let's move back to the ones place. Okay, so which number is smaller? Again, between the 8 and the 6 is smaller. So 6.195 is going to be next. 6.195 is next. All right, and last but not least, that leaves us with the 8.6. 8.6. All right, so going from least at the top to greatest at the bottom, which one is third? The third one is the 6.195 chicken, or the breast chicken. So answer choice D is correct. Question number 6 reads, Deidre rents B booths at a market. Each booth costs $32 to rent. Deidre pays an additional $30 in fees for a total of $94. Complete the equation that can be used to find how many booths Deidre rents. Move the correct answer to each box. Each answer may be used more than once. Not all answers will be used. All right, so the first thing that sticks out to me in this question is the use of a variable. Deidre rents B booths at a market. B booths at a market. That sticks out to me. What's the use of the letter B? The use of the letter B is a variable. It's just showing us that there's a certain number of booths that Deidre rents, but we don't know how many. So it could be 5, it could be 10, we don't know. But that's not important right now. What next sticks out to me is the fact that each booth costs $32 to rent. So if we have, let's say, 5 different booths at the market, each is going to cost $32 to rent. Each is $32. All right, so what type of math function are we using in this sense? Well, if I want to find the total number that all these booths are going to cost Deidre to rent, I can maybe add 32 5 times, right? But I see a special word in the question, each. The word each. Whenever I see the word each, that reminds me that I'm not going to be adding. Instead, I'm going to be multiplying or dividing. But in this case, we're not dividing, we're multiplying. Division is for when we want to get a smaller number. Multiplying is when we want to get a bigger number. And right now, I understand that each booth costing $32 means that when everything is combined, we're gonna get a bigger number. right? So if B is maybe 5 and each is gonna cost $32, then that means we're gonna have to multiply, all right? So that means that this first box is going to be a multiplication sign, all right? Now it reads, the question continues to say that Deidre pays an additional $30 in fees for a total of $94. All right, so there's an additional fee. What does this mean? Are we adding, are we subtracting, are we dividing, or multiplying? Well, the key word is additional. In this case, we are adding, right? Let's paint this picture. Let's say you go to a restaurant and you order 2 large pizzas, right? You order 2 large pizzas. Each pizza costs $10, okay? Each pizza costs $10. And let's say the waiter is a very nice waiter. The waiter is like, hey, I think I gave you guys good service today. I want a $5 tip. Now, I've never heard of a waiter request a tip before, but in this case, this waiter does. And so at the end, we're left paying, instead of $20, we're paying $25. How do we get that? Well, we took 10 and we multiplied it by 2, right? So each of these pizzas costing $10 means the grand total for the pizzas alone is $20. But now on top of that, we're having to add the tip, all right? And so that means our grand total is $25. So how did we get 25? Well, we had our 20 from the pizzas and we added the tip. It's an additional cost, all right? So going back to our problem, Deidre pays $32 for each booth. So each booth costs $32. Then on top of that, there is a $30 fee that she has to pay. All right, so between the B and the 30, we're gonna be adding, right? And so if we write out this equation, it's gonna look something like this. 94 is gonna be equal to 32 times B plus 30. All right, and if you remember PEMDAS, you remember that you multiply first before you add. All right, because PEMDAS is P parentheses, E exponents, M multiplication, D division, A addition, and S subtraction. So multiplication comes before addition. So in total, this is the correct answer. Question number 7 reads, a rectangular sign is 4.22 feet tall and 6.5 feet wide. What is the perimeter of the sign in feet? All right, so when we have questions like this, I think it's always best to kind of draw out the shape provided. So on the side here, we have our height or length, and then on the bottom, we have our width. All right, so it's 4.22 feet tall, so that's going to be our height. All right, so let's label this 4.22 feet tall. All right, and then it's going to be 6.5 feet wide. All right, now if it's 6.5 feet on the bottom, it's definitely going to be 6.5 feet on the top and 4.22 feet on the other side. All right, so now how do we find the perimeter? Remember, the perimeter is the length of all of the sides. All right, it's the length of all of the sides. So you can add all of these up, or you can multiply the height by 2, the width by 2, and then add those two numbers together. So let's go ahead and multiply. So we have 4.22 feet. 4.22 times 2. It's going to get us a 4 here, a 4 here, and then 8. So we have 8.44. Then we're going to do the same thing with 6.5. And we get 13. And then we're just going to add both of these numbers together. So we have 13.0 plus 8.44. What do we get? We get a 4. We get another 4. That's our decimal point. We have an 11 here. So our answer is 21.44, which means C is the correct answer. All right, question number 8 reads, an equation with a missing quotient is shown. What is the missing quotient? Move the correct answer to the box. All right, so here we have 1/9 divided by 18. Now, how do we divide fractions? This is actually very simple. Whenever you have a fraction, right, in this case we have 1/9, okay? We have 1/9 divided by 18. We have 1/9 divided by 18. Now, how do we solve this? Well, when you're dividing by fractions, it's best to make sure that both numbers are represented as fractions. All right, so in this case, 1/9 is a fraction, but 18 is not a fraction. How do we turn 18 into a fraction? We simply place it over 1. Remember, whenever you're dealing with fractions, anything over 1 is itself. So if I want to turn 9 into a fraction, I could simply do 9 over 1. If I want to turn 10 into a fraction, I could simply do 10 over 1. It's the same thing with all numbers, all right? Any number you want to turn into a fraction, just put it over 1. All right, so now that we have turned 18 into a fraction, what's next? Well, you have to realize that you can't divide fractions. Now, what do I mean by that? In order to divide, and I say divide in quotes, right? In order to divide a fraction, you actually have to multiply it. What does this mean? Here's how we're going to solve this. We're going to bring our 1/9 over, so that stays the same, but everything else we're going to flip it, okay? So we're going to flip this division sign into a multiplication sign. All right, so it's going to be 1/9. Instead of divided by, it's going to be times. Then we're going to flip this 18 into a 1 over 18. All right. So we're going to flip that into a 1 over 18. All right. So here is how we solve this problem. So now we have 1 over 9 times 1 over 18. Now, how do we solve this? We simply multiply straight across. We multiply straight across. All right. So let me create some space over here. Let me erase some of this so that we have some space. So now all we're doing is multiplying. So we're going to take our equation. Let's bring it over to this side and let's solve it. So 1 times 1 is 1. 9 times 18, let's solve that together. 18 times 9, it's 9 times 8, that's 72. 9 times 1 is 9, plus 7 is 16. So we get 1 over 162. And that is our answer. Alright everyone, that brings us to the end of today's video. If you found it useful, I'd really appreciate if you could give this video a like. Also, maybe share it to a student that could maybe benefit from this type of content. Remember, in the future, we are going to other grade levels for STAAR test prep, so make sure to subscribe so you're updated when we do release those videos. Also, if you'd like one-on-one tutoring for your student, don't forget to check the link in the description. There you can access the sign-up link for Checkmate Scholars. Remember, for new Checkmate Scholars customers, you do get 1 hour of free tutoring, so don't let that opportunity pass you by. Sign up today. As always, I'll see you in the next video. Until then, checkmate.